Okay. All right. So today we're looking at facts. Oh, sorry. Hey, sophomores. Okay. All right. So today we're starting. We're still in chapter 5. So it's polynomials, and again, it's everything that you learned in quadratics with x squared still applies. Okay. It just gets bigger. Like when we used to have just 2 solutions, now we might have 3 or 4. When we used to have just 2 factors, now we might have 3 or 4 or 5, all right? So this little chart is a little bit like a life cycle of the polynomial. So mix a little biology here. So this just kind of talks about all the different stages that a polynomial can take on, and it's the same as what a quadratic could, right? So we have standard form, then we can take it from standard form into factors, right, that might have parentheses and GCF, look something like this. We can take those factors and we can set equal to 0 and solve. And if we do that, then the factors become solutions, right, or zeros, or roots. And then we're not going to graph in this section or this chapter, but if we wanted to, then even when we find out what x equals, we could actually put those on the graph, and they become x-intercepts. Okay, so everything we learned about this with quadratics still applies for higher ones like cubics, quartics, etc. So first we're going to just take this example, 3x cubed minus 12x squared minus 36x, and kind of just take it through the little life cycle chart, okay? So it's in standard form, right? All the multiplying's been done, all the terms are combined, and it's in decreasing order, so it's in standard form. So how can we look at this and go from standard form to factors? What's that? Take out 3, what else would we take out? An x, right? So we can factor this, take out a 3x, and we get x squared minus 4x minus 12. Right? Now, how can we go further? We can go further. We can look inside the parentheses, right? Because now this is a quadratic, so how can we factor that? That's your question, right? So it multiplies to negative 12, adds to negative 4, negative 6, positive 2, right? So now we've gone from standard form to linear factors, right? So the linear factors of this equation are 3x, x minus 6, x plus 2. Okay? Now, to go from factors down to the zeros, or the roots, we can set each one of these equal to 0 and solve. So again, same thing we did last chapter. Okay? Now, if we're going to graph, and we'll graph next year more in pre-calc, then these solutions actually become points on the graph, and we could do a little bit more analysis and connect them the way they need to be connected. Okay? So exact same relationship through each stage that we have with quadratics happens with polynomials. Okay? All right, so all we're going to do today is start down the bottom, like if we're given a 0 or a root, if we start down the bottom and try to go back up to the top. Okay? All right, so, well, girls good back there? Okay, so, what's that? Okay, well, you can just sit back and relax and watch if you want. Okay, and watch the video later and hear it all again. Okay, so we want to write a polynomial function in standard form when we're just given the zeros, okay? To do that, we have to create factors first, and then multiply them together, combine like terms, and write it in standard form. Okay, so similar to what you did on your homework, only we're starting from x equals a couple numbers. So the main thing you have to memorize here is that when you're creating a linear factor, you are just going to plug in x minus whatever number you were given. Okay? And you just have to memorize it, that it's x minus that number. Okay? It all goes back to the way that we factored and we said it equals 0 and it changed signs, right, from the factors to the actual 0. So you just have to memorize it's x minus that number. So, for instance, if we are given that the zeros of some polynomial are negative 1, 2, and 3, and we want to find out what that equation is, we are going to plug in x minus negative 1, x minus 2, and x minus 3. We can clean this up a little bit, right? X minus a negative 1 is actually x plus 1. And the other two are already simplified. So now we have to multiply these together. So it's multiplying 3 binomials, right? So we can use FOIL to a certain degree. So there's many ways to do this. It really doesn't matter the order that you multiply these together. Okay, I'm going to show you the way I do it, because I think it's kind of the most simplified way. But if you have learned somewhere in a different order, that's fine too. But I think the easiest way to do it is always start with the last two, okay, and FOIL those two together. So if I FOIL this together, I get x squared minus 3x minus 2x plus 6. If I combine those terms, I get x squared minus 5x plus 6. So I took care of those two terms, or those two factors. Now I have to multiply in that third factor. And on this one, you can't really FOIL, right? Because FOIL only takes care of multiplying two terms by two terms. So what we're really doing here is we're going to distribute x plus 1 into this equation. And the easiest way to do it is first you're going to take, the goal here is to make sure x gets multiplied by everything over here and 1 gets multiplied by everything over here. So the way we're going to do it is first we're going to distribute that x to everything. Then we're going to keep going and distribute that positive 1 to everything. Okay? So it looks like this. So x times x squared is x to the third. X times minus 5x is negative 5x squared. X times 6 is 6x. Now, here's the tricky part. We're going to keep going. We're going to make a really long equation and distribute that 1. So 1 times x squared is plus 1x squared. 1 times negative 5x is negative 5x. 1 times 6 is 6. So the biggest mistake people make is like distributing the first one and then coming back and distributing the second one like on top of what they already did. Okay, you don't want to do that. You want to build a big old long equation. Okay? So now we just combine like terms. So we only have 1 x to the third, so that comes out by itself. What else can we combine there? X squared. So we have negative 5x squared plus 1x squared is going to be negative 4x squared. What else can we combine? X's. So 6x minus 5x is plus x. And then we have plus 6. And we're done. Okay, so we went from what the zeros were, we built factors, and then we multiplied them together to get standard form. Okay? That's okay? All right, next example shows a couple tricky scenarios, you might say. Okay? Is it stressful? No. I can understand what you said. Do you have a question? All right. Okay, so let's keep going. So these are little special circumstances you have to think about. Okay, so again, we're given the zeros of 0, 5 halves, and -9. So first, start out just following the rule. So x minus 0, x minus 5 halves, x minus -9. Okay? Now, x minus 0 is really just what? X take away 0, it's really just x, right?
Are you always making them minus whatever?
You always, that's what the first rule was. You always plug them into x minus a number, okay? But x minus 0 is really just x, okay? So you could FOIL it with an x minus 0, but it really just causes more problems than it's worth. So that can always just be written as x, okay? Now, x minus 5 halves. Nobody wants to FOIL a fraction, right? That was just like foiling for all of us. So what you want to do is take, and it's just a little trick, take the denominator and move it out in front of that 2. So this becomes 2x minus 5. And again, when you think about it, this is what your factor would look like when you were to solve it and you would get 5 halves, right? X would come the other way. And then x minus 9, x minus -9, we've seen that already, becomes x plus 9. So now, how should we simplify it? Okay.
Are you moving numbers just because you're multiplying out 2 on those sides?
Well, this is not an actual equation, so there's no, like, we have to do to one side. But this is just, if we took this factor and set it equal to 0, we would get 5 halves. So we're just kind of making it in this form to make it easier to multiply. You know, because if we tried to FOIL with a fraction, it would get really ugly. So this is just kind of a way to rewrite it, where it's still the same 5 halves, it's just easier to multiply. Okay? So now, to multiply this out, we're going to FOIL these two, and then just distribute that x. Okay? So we FOIL, we get 2x squared plus 18x minus 5x minus 45. Combine like terms, 2x squared plus 13x minus 45. And then we bring down our x, and we get 2x to the third plus 13x squared minus 45x. Okay. Questions about that? Okay, very good. All right. Now, one more thing we're going to look at is just a new vocabulary term called multiplicity. Okay, multiplicity just means how many times a 0 or root occurs. And again, you'll see this on the ACT too, actually. So multiplicity just tells you if a root happens more than once, instead of saying it happens this many times, they just say what its multiplicity is, okay? So if you, for instance, are told that x equals 0 and 5 multiplicity 2, it actually means that the roots are 0 and 5 again. Okay, so multiplicity just tells you how many times that particular root happens. So if this were like multiplicity 7, we'd have 0 and then 5 sevens afterwards. Okay, we're never going to multiply that many out, okay? But it just tells you how many times the number that's right before it happens, okay? So now we have 3 roots, 0, 5, and 5. So again, we would write x, you don't have to write that, but I'm going to show it for now. X minus 0, x minus 5, x minus 5. This actually becomes just an x, right? X minus 5, x minus 5. So now we have to multiply it all together. So what should we do first? FOIL, right? So So we get x squared minus 5x minus 5x plus 25. X squared minus 10x plus 25. And then we bring down that x. So we get x to the third minus 10x squared. Okay, questions about that? So you guys go ahead and try to do this next one. X minus 4, multiplicity 3. Okay, so again, on this one, 4 multiplicity of 3, you first set it up to where x equals 4, 4, and 4. And those all become factors of x minus 4, x minus 4, x minus 4. When you FOIL these two, you should have gotten x squared minus 8x plus 16, right? Now you have to distribute the x minus 4. So again, first I'm going to distribute the x, and I get x to the third minus 8x squared plus 16x. Then I'm going to distribute the negative 4, and I get minus 4x squared plus 32x minus 64. Does everybody agree with that? Is that what y'all are getting? Okay. Now I combine like terms. So I don't have anything that will combine with x to the third. Negative 8x squared minus 4x squared gives me a negative 12x squared. 16x plus 32x. Is that right? Yeah, it gives me 48. I just did something 48x. And then minus 64. Okay? Questions about that? All right, you guys go ahead. We're going to do one more. Go ahead and try the next one. Just the 3, 2, 1. Uh-huh. And here's that last one worked out. Any questions?